So today we are looking at the IIASA Scenario Explorer and database infrastructure. This is to support the ECEMF model intercomparison project. I'm presenting on behalf of the Scenario Services team. So the first part of our toolchain is the IIASA Scenario Explorer. It's an interactive web interface with a database underneath that can be used for model comparison results, for dissemination of results to researchers, and then as data gets published, also to policymakers and stakeholders. Its features include that you can make the scenario results accessible. It also features a documentation section. Model scenario results can be managed for large-scale comparison projects, and we also have post-processing options available, such as the magic simple climate model. Currently, the IIASA Scenario Explorer is used in a variety of different projects. As you can see, we have the Open Entrance, Engage, Navigate, IPCC, ECEMF, and Copernicus, to just name a few. We also offer a database API so that you can directly interact with the underlying database underneath the Scenario Explorer. We have currently available packages to do so in Python. There is also a package available in MATLAB, and for R, there is a package that is currently being developed. This REST API you can use to develop your own visualization websites and tools. One of these examples is the Scenario Finder, which was implemented as part of the climatescenarios.org homepage by a colleague from FH Potsdam. Documentation about how this API works can be found under the link shown here on screen under software ECE IIASA ACAT/IXMP server. The next part of the toolchain is the IEMC template. This is a standardized template for comparison of scenario results. This was developed by the IEMC. It's used in the IPCC reports, AR5, and the special report on the 1.5 degree warming, and the various Horizon 2020 projects such as ECEMF, CD-Links, Navigate, and Engage. It's currently being used by around 50 teams globally. The sort of structure of this is based around Microsoft Excel files, and it has quantifiers, which are model, scenario, region, variable, and unit. And then it has time series data. So it has these model, scenario, region, variable, unit types that specify what kind of time series it is. And then you have years for which you have a given value. Currently, as you can see, we only have resolution in years, but for the Horizon 2020 project, there is currently a sub-annual time resolution in development. Details can be found on the GitHub page of the Open Entrance project under Nomenclature. Brings us to the next point. Especially in the beginning of a modeling process, it is very important to standardize the variables, units, and so on and so forth that are being used. In order to do so, for the Open Entrance project, there is a nomenclature was developed to for this purpose. It is maintained on GitHub, so discussions and version control can happen there. It's based on YAML text files, which have the advantage of being both easily readable for the human as well as the computer. Also, that this nomenclature package provides some additional features which are very useful, such as ISO 2 to ISO 3 country mappings and the NUTS hierarchy mappings. This also includes an installable Python package called Nomenclature, which is very useful to be used offline. So you can download this open source package, install it on your local machine, and run validation or various mapping tasks. The details can be found, again, as in the previous slide mentioned, on github.com, the Open Entrance page under Nomenclature. The sort of final piece of the puzzle is a Python package called Payam. which is used for scenario processing, analysis, and visualization, and it is following current best practices for collaborative scientific software development. As said before, the main use cases are for data processing, validation, and analysis and visualization. It can be found on GitHub, and it currently supports multiple different Python versions. The next steps now, as you start the modeling process, the first step is very important, is to automate your workflows, as these kind of model comparison projects feature a lot of repetitive steps, which of course are error prone. It is a good idea to automate them. One of the tools that you can use for that is the previously mentioned Payam package. So to kind of load the results from your IEM, maybe wrangle them a little bit, validate them, and then upload them to the Scenario Explorer. In order to do so, that's the second point, you need to create an account if you haven't done already. You see the link where you can do that. If you have a model that you want to register, you have to write an email to hoopman@iasa.ac.at, clearly stating the model name and the version number so that this will become available. Fourth point is the testing phase. So you would, as a first point, you would test an upload with a minimal data file. So you would have a few dozen rows where you just can see if everything is working nicely. With the real data, we recommend that you first run the validation locally, perhaps in a Jupyter notebook, using, for example, the Nomenclature package. Once you have done that, you can do a test upload of the full scenario just to see that everything is working. And as soon as that works, yeah, you can work away, do first upload of the full scenario file, and then share and discuss. If there are more Q&A sessions or tutorials required, we can schedule those. Yeah, this is it for today. Thank you very much for your attention. I was presenting on behalf of the Scenario Services team. Thank you very much.